The WristMotion Total Arthroplasty system comes with one instrument tray. This is the top deck of that tray, and it's used to prepare the carpus, and then we also have a bottom deck that's used to prepare the distal radius. If you're familiar with our Hemi system, a lot of these instruments will look familiar. These are basically essentially the same as what we offer. And then there's additional instruments used to make the carpal cut and also prepare and deliver the bone screws. The carpal implants are available in 3 sizes, small, medium, or large, and to determine the correct size you use a very similar guide to the Hemi system. One small difference is that what was a 12 millimeter previously is now a small, and what was a 15 millimeter previously is now a medium or large. So if you select the medium or large size, you're going to use the medium large reamer or the medium large cut guide, and then when you get to trialing between the large and medium, you'll select the implant that gives the best coverage in what you want. If you use a small, you're also going to have to use a small radial component. However, if you choose the medium or the large on the carpal side, you can interchangeably use a medium or large on the distal radius depending on the coverage you like there. So this is the bottom deck of our instrument tray. It has all the instruments that you'll need to prepare the distal radius. All of the components are color coordinated, so if you're choosing a small radial component, you're going to be working all in this block, or medium or a large. And then you have some universal instruments that are going to be used no matter what size. Like I said previously, if you are using a small carpal component, you're going to have to use a small radial component. And if you choose a medium or large, you could select either the medium or the large on the radial side, depending on the coverage that you like. So aside from having small, mediums, and larges, we also offer 3 offsets for our poly, which is on the distal radius. So we have a +0, a +1.5, and a +3 millimeter. Using the carpal drill guide, determine the appropriate size carpal component. To do this, you're placing the carpal drill guide over the head of the capitate and determining which one covers the head best without significant overhang. The size options are a small or medium/large. Again, if you use the size small, you're also going to be using a small distal radius component, and if you use a medium/large, you'll be choosing the medium or large component when trialing, and then you can use a medium or large distal radius component. For the rest of the technique, we'll be using a cannulated power drill. Place the carpal drill guide over the head of the capitate and drive the 1.5 millimeter guide pin until the laser line is flush with the back of the carpal drill guide. Using fluoro, ensure that the guide pin is centrally located in the capitate in both planes. The system includes a quick connect driver which is compatible with all of the system's drills and reamers. Drive the carpal twist drill over the guide pin until the shoulder of the drill is flush with the articular surface of the capitate. Using the carpal tap the pilot hole until the etched laser line is flush with the articular surface. Insert bone cement into the pilot hole. Using the carpal hex drive, drive the taper post over the guide pin until the etch mark on the hex driver is flush with the articular surface. Choose the appropriate size carpal reamer based on the carpal drill guide. In this case, I'm using the medium/large, and drive over the guide pin until the nose of the reamer bottoms out on the screw. The carpal reamer needs to bottom out on the taper post to ensure that the Morse tapers can lock. Remove the guide pins, and if necessary, use a rongeur to clean up any remaining bone. Place the DF reamer into the taper of the taper post. Align the guide so that the reamer is coming down from the 12 o'clock position and ream until the shoulder makes contact with the back of the DF jig. Up until now, the preparation has been the exact same as the Hemi system. Now we're going to prepare the bones by making the additional carpal cut and delivering the bone screws. Choose the appropriate carpal cutting jig based on the appropriate size determined by the drill guide. Again, in this case, I'm using the medium/large size. Place the guide into the back of the taper post and pin in place. Using a sagittal saw, remove the proximal aspect of the hamate and scaphoid by placing the blade flush with the jig while cutting. Once the bones are resected, remove the tack pins and carpal cutting jig. Now we're going to prepare the distal radius. We're going to walk through the key steps, but please refer to the technique guide for the full detailed instructions. As we mentioned previously, if you use a small carpal component, you're going to have to use a small distal radius component. But if you use a medium or large, you get to choose at this point if you want to use a medium or large radial component. And the way you're going to select that is basically choosing which one gives you the coverage of the distal radius that you like better. We're going to use the medium for this one. To place the guide, you're going to align it in the center of the distal radius and then shift it ulnar until the aiming feature is just at the limit of the bone or slightly over the distal radius. That will ensure that the TFCC is preserved in the future reaming. So you don't want the aimer actually over the TFCC. So once you have the placement you like, we're going to shoot a pin and then check it with fluoro. When you're checking this pin shot, the pin will be tilted about 5 degrees ulnarly, but the more critical check is that in the SI plane, it's centered in the IM space. This will ensure that the stem is positioned correctly. With the cannulated power drill, drive the radial starter drill over the guide pin until the laser line depth indication is flush with the articular surface. Place the radial V-guide into the drilled socket, and again make sure that your rotational position is correct before pinning it in place with the guide pin. The shank of the radial core drill is a 2.7 millimeter diameter and can be driven with the standard pin driver attachment. Advance it through the V-guide until the shoulder of the core drill bottoms out on the guide. We're going to start with the radial hole first, and then remove it, and then drill the ulnar hole. The system comes with 2 of these, so after the first drill, you can just get rid of the first one and rechuck the second. Remove the radial V-guide and the guide pin. At this point, I like to use a rongeur and clear out any web that remains between the 3 holes. That'll make subsequent broaching a little bit easier. Thread the appropriately sized depth guide onto the radial inserter. There's a right and left for each size, so ensure that you have the correct side. Confirm that the dorsal side is face dorsal and impact into the hole. You'll know you're finished when the ulnar aspect of the guide is about 2 millimeters sub-flush. Unthread the radial inserter and remove it. Place a tack pin into the 2 millimeter hole in the radial depth guide. Take the appropriately sized radial surface reamer and drive it over the guide pin until the nose of the surface reamer bottoms out on the radial depth guide. Remove the tack pin, rethread the radial inserter, and remove the radial depth guide. A mallet strike on the back side of the radial inserter will pop out the radial depth guide. With the rongeur, remove any of the remaining bone that prevents the implant from fully seating on the distal radius. Select the appropriate radial stem and thread it onto the radial inserter. Insert bone cement and impact the radial stem into its placement. Remove the radial inserter. Select the appropriate thickness radial poly trowel to achieve the desired joint tension. Select the correct carpal articular trowel to achieve the correct carpal coverage. For the medium and large carpal implants, we're now at the troweling step. Again, if you've selected a small, you're going to stick with the small. But because we did the medium and large, we get to choose between two trowels now and see which one gives us better carpal coverage. The trowels also have holes that will show you where the auxiliary bone screws are going to go. So you want to make sure that they're centrally located in the two outer bones. Select the appropriately sized carpal plate. Clean the taper post taper with the taper post cleaner. Also ensure that there's no debris that would prevent the plate from fully seating, and place the taper connection of the carpal plate into the taper post. With the carpal impactor and a mallet, impact the carpal plate to seat and lock the tapers. Position the bone screw aiming probe into the radial hole of the carpal plate. There's an interfacing feature on the aiming probe that registers in the plate, and the distal end of the probe rests on the second met to ensure an accurate pin shot. Using the system's 3.2mm drill into the base of the second met. The laser line on the drill will indicate the correct length screw to use. Using the system's bone screwdriver and the appropriately length bone screw, begin to drive through the radial hole. We're going to take this screw all the way down to the locking thread but not engage the locking thread. Using the system's bone screw depth gauge, repeat the steps on the ulnar hole. Manually extend the 4th and 5th metacarpal and drill until the distal cortex of the hamate. Again, use the gauge on the guide to determine the correct length screw. Using the bone screwdriver and the appropriate bone screw, drive the bone screw into the hamate through the ulnar hole of the carpal plate. As the locking threads begin to engage, alternatively tighten both until they're fully locked. Clean the carpal plate and remove any debris. Align the taper feature of the carpal articular with the carpal plate. Using the carpal impactor, seat the carpal articular. After the final radial poly trialing, select the appropriate poly component and impact using the radial impactor.